Hi ladies and gentlemen, I need you to turn to your notebook where you can find the pages on periodic table. Okay, you would have already completed the SLS lesson on the periodic table, alright, with watching the videos to better understand the trend that's explained. Over here, I'm going to do a quick summary based on the content of your syllabus so that you are more prepared for the assessment. Okay, I'm going to go through first the periodic trends. Okay, which means trend in the periodic table. Okay, first, elements in the periodic table are arranged according to increasing proton or atomic number. Okay, ladies and gentlemen, in your periodic table, you are actually given the key. Alright, in this key, it is stated that this top number, alright, is actually the proton or atomic number. Okay, the bottom number is the relative atomic mass. However, in your assessment, we will represent in Euclid notation. You have done Euclid notation in in term 2, alright, under atomic structure. So for example, if I were to write lithium, alright, for your assessment in any of the question, it will be written as lithium 37. Alright, what I need you to take note that it is always the small number. Alright, the small number. Alright, but sometimes, okay, the small number, alright, will be the proton or atomic number. Okay, so please take note. The only element that do not have a small value for the proton and atomic number is actually hydrogen. Okay, hydrogen has 1 proton, so and the mass is also 1, so meaning that it is the only element that doesn't have a small number as a proton or atomic number. Okay, so do take note, point number 1 is a very popular MCQ question. Okay, number 2, a group is a vertical column. Alright, so that's the next definition. Alright, is a group, right, is a vertical column of elements in the periodic table, and it corresponds to the number of valence electrons. Okay, so what does that mean? So if I were to look at the representation, so which means that, okay, this is group 1. Okay, apologies for that. Okay, so the vertical column, alright, this is group 1. Okay, so it corresponds to a number of valence electron. What does that mean? So if I were to write the atomic number of the electronic structure of lithium, so electronic structure of lithium with proton number of 3 will be 2.1. So if I were to write for sodium, Na11, it will be 2.8.1. If I were to write for potassium 19, it will be 2.8.8.1. So if you look at these 3 elements, the similarity is, alright, okay, the one that I underline, alright, so this one here, right, indicates the number of valence electrons. So for group 1 elements, they actually have 1 valence electron. Valence electron is the electron in the outermost shell. Okay, that's the meaning of valence. Electron in the last electron shell. Okay, so that is what it means by number of valence electron. So if let's say I move on to the next group, okay, the next group, let's say here, right, which is beryllium. Okay, so beryllium belongs to group 2. So what does this mean? That all the elements will have 2 valence electrons. And do take note, for the group it is written in Roman numerals. So you just have to follow, okay, what is written here. So if for example I have group 3, okay, so like that. Okay, so all these elements, they actually have 3 valence electrons. This is regardless of positions of the elements in the periodic table. Okay, and so on and so forth. So meaning that if you have for example here, right, fluorine, right, the group 7, okay, so this means that I will have 7 valence electrons. Okay, next. Here first you have the group. Now let's go to the period. So what is a period? Okay, a period is a horizontal row of elements, okay, corresponds to the number of electron shells. Okay, so what does it mean? So if I want to start drawing, so it means that, okay, it's a horizontal row, so I will draw more on the right, so which means from here, alright, starting from here horizontally, this is period number 1. So when I say period 1, means this element has 1 electron shell. Okay, so what does it mean? So if let's say I were to draw hydrogen and helium, okay, right, so if let's say it's hydrogen, alright, the proton number is 1. So if I were to draw hydrogen, is just with 1 electron, so it is 1 electron shell. So if I have helium, okay, helium has proton number of 2, so 2 electrons also, so helium like that. So which means I draw helium, which means the electrons are in the first electron shell. Okay, so horizontal row means corresponds to the number of electron shells. Right, so it's here. So this is period 2. Okay, period 3. Okay, this is period 4. Okay, period 5. Okay, this is period 6, and last but not least, period 7. So which means in the periodic table, right, you actually have 8 vertical column of groups, okay, and 1 and 7 periods. So which means if I were to ask you how many electron shells does, let me see, indium have? Okay, so let's say if the question is how many electron shells does indium have? Okay, so you look for the element indium. Indium is where is indium? Here. This one is indium. That's iridium. Oh, that's indium. Yeah, yeah. Okay, so what you do is, okay, so if you were to look here, okay, now I am looking at horizontal row of elements. Okay, so long as I belong to this horizontal row, okay, all these elements, alright, will actually have 6 electron shells. Okay, so which means any of the elements that I highlight inside the box, alright, so it will be 6 electron shells. Okay, so if you were to ask for the number of electron shells for let me see, rudabnium. Okay, so what you do is, any of the elements here, okay, so let's say if I have this element, okay, so which means this element will have 7 electron shells. Db, alright, will have 7 electron shells. Okay, so if they were to ask you which row, which group and which period does element bismuth have, so for example, if this bismuth here, okay, so example for bismuth, which group does it belong to? So for group is this one here. Okay, so which means group is 5. Group 5, so the inference is it has 5 valence electrons. Okay, so which period? Okay, period 6, right? Because bismuth is here, so it's period 6. So 6 means I have 6 electron shells. Alright, so this is the information for the first part of the section on page 69. Okay, as and when you feel that you need more time to copy, alright, so please pause the video. Okay, next we are going to go to the trends in the periodic table. Okay, when they say across means horizontal row. Okay, it is horizontal, so which means that I will have to go in my purple line. Okay, so this is across, starting from here it is across. Okay, trends across the periodic table. Okay, so just look across. So if they say proton number increases, so you look at the proton number. Proton number is the smaller number. So if you look at the smaller number, okay, let's look here. This is 1. I move across the period. Okay, it increases. Oh, sorry, wrong value here. So sorry. Okay, so which means first for hydrogen it has a proton number of 1, helium has proton number of 2. As I move down, okay, lithium has proton number of 3, beryllium has 4, boron has 5, carbon has 6. So this explains the number of electron shells, number of protons in the nucleus increases. Okay, this section on atomic radius you can cancel because it doesn't apply to you. Okay, so you can cancel this. So this section here you can cancel. Okay, as you move across, the number of valence electrons increases. Okay, so what is the explanation? If you look at the group, okay, if you look at a group, okay, elements in group 1 has 1 valence electron. Okay, then after that 1, 2, 3, right, 4, 5, 6, 7 and so on. Okay, so which means as you move across, the number of valence electron increases. Okay, next, for here the types of oxides, this one will be covered in term 3. Okay, metallic property and non-metallic property, what does it mean? Okay, on the left of the side of periodic table, you actually have metals. So metals tend to lose electrons and form positive ions. Okay, and then when you move across, it becomes more and more negative. So what does it mean? Okay, so when you get the periodic table, your teacher will always tell you this. Okay, so I'm going to highlight the non-metals. Okay, my non-metals start from boron onwards, so I have to draw this staircase line. Okay, you need to link back to the topic on atomic structure and bonding. Okay, and plus hydrogen. Okay, so the one that I put in highlighted in green, this, alright, using my highlighter, right, these are actually non-metals. Okay, so which means that within here, okay, I know there's multiple colors, these are non-metals, and this also includes group 0. Right, group 0 are also non-metals. Okay, so includes all those elements in the green highlighter plus group 0. Okay, so which means on the left of the periodic table, okay, so here these are metals, group 1 and group 2 are metals. Alright, the one highlighted in green are non-metals, so which means metals start for group 3, the metals start from aluminium downwards. Okay, so which means these are metals. Anything below here like germanium, okay, all these below here, okay, antimony, bismuth and polonium. So all those I put in black, they are all actually metals. Okay, and what about all these elements in the center of the periodic table here? Okay, this section here, these elements, right, these are metals too. Okay, so these are also metals. Okay, one characteristic of metals, it will always lose electron, and alright, from left to right, metals lose electron, non-metals will gain electron. Okay, I'm going to give you an illustration of that. Okay, so if let's say you look at group 1, okay, I'm describing metallic property. Metallic property means the ability to lose electrons. That's why you are a metal. Okay, so metals lose electron, non-metallic is actually gaining electron. Okay, next, so for example, if I have sodium, okay, sodium is the simplest element, okay, it will be 1123. Okay, so always remember the smaller number is the number of electrons also. So here it will be 2.8.1 for its electronic structure. So for sodium, because I have one valence electron, so it is easier for me to lose one electron. Okay, when I lose one electron, I become a 2.8. Okay, so let me draw this in diagram form. So if let's say I have 2.8.1, okay, sodium, right, 2.8.1. Okay, because I want to obtain stable electronic configuration, so it is easier for me to lose one electron. Okay, so from here, the process is I will lose one electron. So what happens to me is I will form a positive charge ion. Okay, so when you lose one electron, you become positive charge. Okay, so on the left hand side, metals tend to lose electrons and they form positive charge. Moving across is a higher tendency for the element to gain electrons and form negative ions. So what does that mean? Okay, so I'm going to explain it over here. Okay, so for example, I take one element called fluorine. Okay, so for fluorine, my atomic number is 919. Okay, that's a mass number. So if it's 9, my electronic structure will be 2.7. Okay, so for 2.7, it is easier for me to gain one electron. Okay, so when I gain one electron, I have 2.7 plus 1. Alright, so I will form a minus charge. So I'm going to represent this in diagram form. Okay, fluorine. Okay, 2.7. So after that, it is easier for me to gain one electron. Okay, so when I gain one electron, I will have 2.7 plus 1. I will show you later why is it a plus 1. Okay, you actually have learned this under the topic of ionic bonding. Okay, so this is an application of it. Okay, where does the plus 1 come from is the electron that I gain. So electron that I gain, your teacher will have taught you that you have to put a different notation. Okay. Okay, so after that, after gaining one electron, need to draw bracket. Then it's a minus. Okay, so that is what it means that on left hand side, metal tends to lose electron and form positive ions, and because on the right hand side I have a non-metal, so non-metals will actually gain electrons and form negative charge ions. Okay, so let's highlight this important point here. Okay, metals tend to lose electron, form positive charge ions. Okay, then moving across, metals, right, non-metals, okay, form negative ions, okay, because they gain electrons. Okay, that is the explanation. Okay, now we are going to look at trends down a group. Okay, trends down a group. Then trend down a group means from top to bottom. Okay, proton number increases. Okay, I'm not going to go back to the periodic table. I'm just going to show you here. So for example, like lithium, proton number is 3, sodium, proton number 11, potassium, proton number 19. Okay, do take note. Alright, this is the nuclear notation. So always remember that the smaller number, it is the number of proton. So it is this number you're looking at, smaller number. Okay, so the smaller number is the number of proton. Okay, moving down the group, the proton number increases. Number of valence electrons remain the same. So what does it mean? So with this, if I have 3 protons, means I have 3 electrons. So this would mean 2.1 for my electronic structure. 11 means that it will be 2.8.1. 19, right, 2.8.8.1. So as you move down from top to bottom, okay, the number of valence electrons remain the same. Okay, so this shows, the one that underlined means that the number of valence electrons remains the same. Okay, so which means moving down the group, number of valence electrons remains the same. So the example of this is here. Okay, chemical reactions is similar. So what do they mean by that? So if I have one valence electron, for example like group 1, right? Okay, group 1 elements, right, because they are in group 1, they will tend to lose one electron. So when you lose one electron, you form positive one ion, positive charge ion. So for example, if lithium, okay, lithium is 3, right? So you have electronic structure of 2.1. So the process is I will lose one electron. So I will form Li plus. Okay, always remember the number of electrons you lose will indicate the charge. So for example, if I have beryllium, okay, beryllium has proton number of 4, mass of 9. So I'm looking at this number here. So here beryllium will be 2.2. So for 2.2, it will lose 2 electrons. Okay, when you lose 2 electrons, alright, you actually become Be2 plus. Alright, so if for example I have group 6, I take the example of oxygen. Okay, oxygen, okay, the symbol is O, so it's 8 and 16. Okay, so for oxygen, the electronic structure will be 2.6. So for 2.6, it will actually tend to gain electron. Gain how many electrons? Gain 2 electrons. So when it gains 2 electrons, what charge will it form? It will form O2 minus. Okay, so this is related to the content that you have learned and the concept under the topic of atomic structure and bonding. Okay, ladies and gentlemen, I will stop here for the time being. After this, I will go through the student practice question in this same booklet. Alright, in the meantime, alright, please take time to digest what is being taught. Thank you.